Okay, so we've been talking about combustion in class, and what combustion is taking a fuel source, generally a hydrocarbon, something that generally is like a C2H6, whatever, and you mix it with oxygen and a spark, and what you get in return is a large amount of energy, with water and CO2 being your main components or your main products after the reaction occurs. So we've been talking about this. We've done some actual experimentation with combustion by burning our peanuts to see how much mass is lost. So today's demonstration is all about kind of getting into the nitty-gritty of this equation and what all of that kind of means in a practical sense. The first three demos will be an alcohol demonstration. Let's go on ahead and go right into those. So go on ahead and set my other bottle over here, get my safety stuff out of the way. I am going to take 1 milliliter, which is barely more than a few drops of ethanol. I'm going to measure it out appropriately. My fuel source out of the way. I have the main ingredients we need for combustion. Those ingredients are our ethanol, C2H6O, I believe is the chemical formula. And we have our oxygen. And now we are going to add our spark. This time I'm going to take 5 milliliters of ethanol. Okay. Fuel source out of the way. 5 milliliters of fuel. Okay. So we got our oxygen, our fuel source, and now we need to create a spark. Flame actually ended up inside of the bottle and melted this a bit and continued to burn inside. So that's one thing to keep in mind. The other thing to keep in mind is, as you can see, there's some residual liquid in here. It comes out to be about 2.5 milliliters, and what we would assume this either is leftover ethanol, which is what it smells like, or water if the water didn't evaporate. If there is any leftover ethanol, we should see this ignite. Aha! Okay, so that was demo number 2. And from demo number 1, I added 1 milliliter of fuel. You saw a very real effect with that bottle moving across the countertop. Then I did it again, but this time I added 5 milliliters of fuel. Same amount of oxygen, and you notice this last time we had 2.5 milliliters of fuel left over that went unburnt. So what I'm going to do this time is add that same 5 milliliters, but instead of making sure I get it primed and get air in there and try and get some of the alcohol to evaporate, I'm simply just going to light it and see what happens. Okay. 5 milliliters of fuel. For the demonstration number 3. So what should have been very readily apparent in this one is we didn't get a lot of combustion. So the question is, between those 3 demonstrations, one where I used 1 milliliter of fuel, one where I used 5, and another one where I used 5, but I didn't shake it. I didn't do this number, I just lit it. What is going on here? Why did I get a very different reaction or a different scenario in each case? I have one substance in two forms right here. I have a piece of wood, just some plywood that I've been making birdhouses with my students with. And then I have the sawdust created from cutting this exact board. So these two substances are chemically identical. However, they are structurally different. We'll start off with a fresh, unburnt piece of wood. Just like that, didn't even need to use an entire match. I've already got a flame on this piece of plyboard. All right, now, so let's go on ahead and see how easy it is to light this match stuff. Now, this sawdust. Now, as you can see, I'm able to get a flame. Used up an entire match already. But I'm able to get a flame when the match is there, but as soon as I take it away, the flame pretty much goes out. And what you can see now is this sawdust is just sitting here smoldering. So let me try it again. Match number 2. Take this away, and I got a little flame started, but once again it's out. What your job is now is to figure out what's going on here. Why was the sawdust? Why does the sawdust continue to smolder, but it will not actually give off a flame? There's some heat here still. There's no heat coming off of this wood anymore, which means somehow maybe combustion is still occurring, but at a very slow rate. Let's focus again. All of your explanations need to come back to this equation. Okay? So, with that, I'm going to put out this smoldering pile of sawdust, and I'll catch you guys later.